You touched your own face this morning without thinking about it, maybe brushing your teeth, maybe wiping sleep from your eyes. You assumed that face was yours, fixed, solid, permanently attached to who you are. But the real answer is far stranger than that. The atoms making up your face right now used to belong to something else entirely, and in a few years, most of them won't belong to you at all. Start with something simple. Look at your hand. Skin, bone, blood, all of it built from atoms. Carbon, oxygen, calcium, iron. None of those elements existed in the first moments of the universe. Not one. Right after the Big Bang, the cosmos was almost embarrassingly simple. Just hydrogen, just helium. A thin scattering of the lightest elements drifting through an expanding void, nothing heavier, no carbon for bones, no oxygen for blood, no iron for a beating heart. So where did the rest of the periodic table come from? It came from stars. Specifically, it came from stars dying. Inside a star, gravity squeezes hydrogen atoms together so violently that they fuse into helium, releasing enormous energy. That's the easy stage. But eventually, smaller stars run out of fuel and fade quietly. Bigger stars don't fade. They detonate. When a massive star runs out of fuel, its core collapses in less than a second, then rebounds in a catastrophic explosion called a supernova. In that single explosive moment, the pressure and heat become extreme enough to forge heavier elements: carbon, oxygen, nitrogen, calcium, iron. Elements that didn't exist before suddenly scatter across space in a cloud of stellar debris. This process has a name: nucleosynthesis. In plain English, it just means atoms being built inside the furnace of a dying star. The astronomer Fred Hoyle, working alongside physicists Margaret Burbidge, Geoffrey Burbidge, and William Fowler, mapped out exactly how this works in a landmark 1957 paper, still considered one of the most important explanations of where matter actually comes from. Their conclusion was almost too strange to believe at the time. Every heavy atom in your body was forged inside a star that exploded long before Earth even existed. Carl Sagan spent decades trying to get people to actually feel that idea, not just understand it intellectually. Across his television appearances, lectures, and books, he kept returning to the same point. The calcium in your bones and the iron in your blood were manufactured inside stars billions of years ago, then scattered across the galaxy by an explosion more violent than anything happening on Earth today. Those atoms drifted through space for unimaginable stretches of time. Eventually, gravity gathered some of that scattered stellar debris into a new solar system, into a new planet, into you. Carbon, oxygen, iron, and calcium come from supernova explosions like the ones Hoyle and his colleagues described. But some elements need an even more violent origin. Gold, platinum, and uranium are too heavy to form even inside an exploding star. For decades, physicists weren't entirely sure where these elements came from. Then, in 2017, the LIGO and Virgo gravitational wave observatories detected ripples in spacetime coming from two neutron stars colliding nearly 130 million light-years away. Telescopes around the world turned toward the explosion that followed, an event called a kilonova, and watched it forge exactly the heavy elements scientists had been searching for. The gold in a wedding ring, the trace amounts of gold sitting inside your own bloodstream right now, almost certainly came from two collapsed stars smashing into each other at nearly the speed of light. Some of the carbon atoms currently inside your body were also, at some earlier point, almost certainly part of something else entirely. Ancient trees, long-extinct animals, maybe even dinosaurs that walked the Earth 66 million years ago, recycled since then through hundreds of millions of generations of plants, decomposition, and regrowth. None of that material disappeared. It just kept moving. Stop and sit with that for a second. The iron carrying oxygen through your bloodstream right now is older than the sun. Is that comforting, or is it unsettling? Here's where things get stranger. You are not a fixed collection of atoms, holding the same matter for your entire life. You are constantly trading material with the world around you, atom by atom, almost like a living, revolving door. Every breath you exhale releases carbon dioxide, carbon atoms that were inside your body seconds earlier, now drifting back into the atmosphere. Every meal you eat introduces new atoms, pulled from plants, animals, water, and soil. Your skin sheds roughly 1 million skin cells a day, carrying their atoms away with them. None of this matter stays put. It moves through you the way water moves through a river. The river keeps its shape. The water never stays the same. So how much of you is actually permanent? A neuroscientist named Jonas Frisane, working at the Karolinska Institute in Sweden, found a clever way to answer that question. Decades of above-ground nuclear testing in the mid-20th century released a radioactive form of carbon into the atmosphere, carbon-14, which plants absorbed and animals and humans then ate. Because the amount of atmospheric carbon-14 changed in a measurable, dated pattern over time, Frisane realized it could function almost like a tree ring, revealing exactly when each cell in the body was formed. His research turned up something remarkable. Most cells lining the gut replace themselves within days. Most skin cells last only a few weeks. Red blood cells survive around 4 months before being broken down and rebuilt. Even the cells inside your skeleton get slowly replaced over roughly a decade. Almost nothing in your body is the same age you are. There's one notable exception. The neurons in your cerebral cortex, the part of the brain responsible for memory, reasoning, and your sense of self, largely stop replacing themselves after childhood. They remain, give or take, roughly the same age as you, which raises an odd question. If nearly every atom in your body eventually gets swapped out and replaced, but a stable network of brain cells keeps firing the same patterns for decades, is your sense of self really about the matter sitting inside you? Or is it about the pattern that matter happens to be arranged into? This is where the idea stops being a science trivia fact and starts becoming something closer to a philosophical gut punch. Think about where those recycled atoms have already been. Carbon doesn't disappear when an animal or plant dies. It returns to soil, to water, to air, and eventually gets absorbed by something else. Oxygen molecules cycle through the atmosphere over and over, breathed by humans, absorbed by oceans, released by trees, breathed again. Calculations by physicists studying atmospheric mixing suggest that, statistically, you have probably already inhaled molecules of air that once passed through the lungs of historical figures who lived centuries ago, simply because gas molecules disperse and mix across the entire planet over time. Not symbolically, literally. The same physical material recirculated. Some of that carbon spent millions of years locked inside coal seams, oil deposits, or ancient limestone before industrial activity finally released it back into the air you're breathing right now. Here's the part that tends to unsettle people the most. This cycle didn't begin with you, and it won't end with you either. The carbon currently sitting in your muscles was, at some point in the deep past, almost certainly part of other living things. Ancient plants. Extinct animals. Other humans who lived and died long before written history existed. And after you die, that same material will eventually disperse again. It will become part of soil, part of new plants, part of new animals, part of people who haven't been born yet. You are not really a fixed object moving steadily through time. You are a temporary arrangement, a pattern that stellar material has organized itself into for a few decades, before dispersing and reorganizing into something else entirely. Does that change how permanent your problems feel? Why does any of this matter outside of a science lesson? Because most human anxiety about identity quietly assumes permanence. People worry about staying the same person, holding on to memories, preserving a stable sense of self, as if identity were a fixed possession instead of an ongoing process. But biology tells a different story. Even your physical body has never actually been permanent. It has always been borrowed material, briefly assembled into a shape that thinks, feels, and calls itself you, before passing that material along to the next arrangement. Ancient cultures across the world independently arrived at strangely similar conclusions long before nuclear physics existed. Cycles of death and rebirth, ashes returning to ashes, dust returning to dust. Funeral traditions in cultures separated by oceans and centuries often describe the body returning to the earth, becoming part of new life. They didn't have carbon-14 dating or supernova astrophysics to explain why. But they noticed the pattern anyway, just by watching forests grow over old graves, watching new life spring from decayed matter, watching the seasons cycle endlessly. Maybe they understood something modern science only later confirmed. Modern physics simply gave that ancient observation a mechanism. Stars die so that heavier elements can exist. Those elements scatter, drift, and eventually assemble into planets, oceans, forests, and bodies. Those bodies borrow the material briefly, cycle it through, and release it again. The pattern never stops. It just keeps reorganizing, generation after generation, star after star. Think about how strange this makes some very ordinary modern habits. People spend money on creams and routines designed to preserve a version of skin that was never going to stay the same anyway. People scroll back through old photos, comparing a past self to a present one, as if the two were the same physical object simply frozen at different ages. They weren't. Even a decade ago, almost none of the atoms in that old photo's subject are the atoms standing in front of the mirror today. The usual assumption that a person changes slowly while some core self stays fixed underneath has it backward. The matter changes constantly, faster than most people realize. The pattern is the part that occasionally feels stable. So consider what's actually happening the next time someone tells you to be yourself. Which self? The one made of atoms that will be entirely different in a decade, or the pattern those atoms momentarily hold? Maybe both answers are true at once, depending on what you're really asking about. So the next time you look in a mirror, you're not looking at something fixed. You're looking at recycled stardust,